Yes, that's right, you've guessed it, we have yet another Nintendo Switch that doesn't power on. I paid £40 on eBay for this, and again, it's in okay condition, not horrendous, and missing the back kickstand. If we can fix today's Nintendo Switch, this will be the third in a row we've been able to sort. But I'm not getting my hopes up yet. Unlike the other ones, the charging port on this Nintendo Switch actually looks okay. We are missing 2 of the bottom screws, and up top, we're also missing this screw as well. The rails of the Switch actually look okay, no problems there whatsoever, on both sides that is. And the model number of today's Switch is XKJ700. So we're going to go ahead and do what we've not been able to do that much recently when testing the Nintendo Switches, and we're going to use our ammeter to see what kind of a draw we're getting. This should give us some clues as to what the actual issue is with the Nintendo Switch and why it's not turning on, potentially. Here we go. Okay, so we get something on the screen, we get 0.11 amps, 0.15, and it's 14.8 volts. That to me is an indication of a good, healthy Nintendo Switch that just has a flat battery. What happens if we try and turn it on? We get nothing, and nothing happens to the amps. What about if we try and charge it the other way? What happens here? Oof, we get the flashing. Okay, all right. That's bad, that's not good. So with this Nintendo Switch, we've got charging on one side, flashing on the other. Let's take it down to the motherboard and see exactly what's going on with it. Actually, I forgot to check and see if we got a game with this Nintendo Switch, and did we? No, unfortunately not. The side screw here on the rail is literally just spinning. It's almost like it's threaded. It's just stuck in there, not coming out. So we can pull it out with the tweezers. Yeah, there we go. I think someone's definitely been inside this, which doesn't provide me with much hope. Speaking of being inside, kabam! It might be rest in peace already to this Nintendo Switch. We have severe water damage on this PCB. Speaking of PCBs, this video is proudly sponsored by PCBWay.com. Creating your own PCB could not be simpler. However, you can also make it as advanced as you want it to be. Enter the dimensions of the board, how many boards you actually like, finally adjust the layers and the thickness, and you're good to go. PCBWay OEM offers you a one-stop solution for your idea. Simply share your thoughts with PCBWay and they'll help you with the rest. From product design, research and development, and of course production. Use the link in the description for a $5 welcome bonus. You can see all around the battery just here we've got tiny signs of corrosion, and then if we get to the coil / inductor, which is just about here, you can see all of the water damage around the BQ area. This little pad, I always have no idea what this is for, but I think it's just protection of the BQ charging chip which is underneath. I'll take this off in a sec to inspect, but what I am hopeful about is that we don't have any corrosion from what I can see yet on the board anywhere else. If it could just stay around about here, that would be perfect. The polka dot sticker has gone from a white and red to a pink and red, which means it's definitely been water damaged. Got to take a sip of coffee before this one. We're now underneath the microscope, and I tell you what, one thing I want to do is check the port before we go any further. Okay, yeah, that is damaged. You can see there's 2 pins here that are split, and one of them is definitely crossing over. I mean, they're both crossing over by the looks of it. That one's touching that one, and then we got one touching down here. On the other side, we seem to be absolutely fine. So I think that would explain the flashing that we had on the ammeter. Let's inspect the rest of the switch. We'll come over to BQ in a second. I just want to check up here on M92, see if there's any corrosion. It looks to be okay. So M92 seems to be fine, but it might not be because of the crossover on the port. Now, if we go over to this absolute bomb site, you can see we had the bit of corrosion around the battery terminal here. This has got a tiny bit of corrosion underneath here. There's a lot of corrosion here. I'm pretty sure with just enough force, you could definitely get that cap off. That cap is charred. Let's remove this and see what the state of BQ is. I was expecting BQ to be in worse off condition, so that's not horrendous. This cap is completely gone. It might still work fine, but it's way too charred for my liking. And then we've got the inductor here, which has obviously seen a lot of water. I don't know if water's come in through the charging port and then it's come around to, I'm gonna guess that's how it got in. And we obviously got this cap as well down here, which again is very, very charred. Don't know if we're meant to have a component here. I don't think we are. There's water damage here. Just having a real quick scan of the board to see if that corrosion made its way anywhere else. Oh, okay. So we have got some corrosion on the backlight ribbon connector and the left or right Joy-Con stick. I don't know which one this is. The micro SD card holder seems to be fine. No corrosion there. And no corrosion on the NAND, which is good. The memory. Do we have anything inside the LCD ribbon connector? That's definitely one to check. Doesn't look like it. That actually looks hunky-dory. I'm happy with that. And the actual connector for the NAND seems to be fine as well. Moving up the board slightly, we've got a tiny bit of corrosion here, which is, I'm pretty sure, the game card reader. That's the FPC connector for that. So I'll give that a clean up as well. But that doesn't look too badly damaged. And now we're going to turn the board over to P13 and see if there's any water damage on the back of this. Oof. Oh wow, that looks absolutely screwed. I remember speaking about this recently. I think this is the audio chip. It might be the audio IC. And as you can see around here, that is not healthy, whatever this slodge is. I have no idea what type of liquid this is. I don't think it's water. But again, these capacitors are really, really charred. I'm just looking on the back of the CPU, which is here, and this seems to actually be okay. So no issues there. What about P13? P13 has also survived the hit. That's really, really good. And do we have, oh, hang about. Oh, Lord. What has gone on here? This is a sore sight to see. Just looking down this side as well. I think over here is where you find the backlight IC. I don't know if the backlight IC is this one or whether it's this one, but it looks like oil. Oh God, look at this. I don't know if there's actually meant to be any components here. I see a little resistor here, but I now have an image in my head of where all of the water damage spots are. So what I'm going to do is quickly clean this up with some isopropyl alcohol before we remove the port to see what the damage is. I mean, it's crazy really. It doesn't look like the same piece of board that I just showed you. So I have no doubt that this Max IC here is probably going to be a BGA, and I won't have the stencils to reball this, but everything is actually cleaned up pretty nicely. I don't know if this is a broken trace that doesn't go through to here anymore, perhaps. So we'll maybe need to test that for continuity. But actually, after a good scrub, it looks okay. Let's also give this little bit a clean up as well. Okay, so again, that looks a little bit better. Still very charred caps. And finally, we'll do BQ. Whilst I'm on a roll, I might as well clean these ones up as well. Let's get this charging port off. We'll go with 450 degrees Celsius with an airflow speed of 50%. Add some flux, extract the fan on, and I'll see you on the other side. I forgot to record, but I've also put down some leaded solder as well, just to ensure that nothing's bridging. And again, quickly give it a clean, isopropyl alcohol, and cotton bud. Again, just making it as clean as we can whilst we inspect and see what's going on. We have our meter set to continuity mode, which is the mode that beeps when we have a complete circuit. A lot of people will be wondering, Joey, you're just probably going to waste your time on this. If it was a money move, you'd be 100% correct. Say, for example, if this was a business where I was trying to repair multiple devices in quick succession. But I can take my time with this because it's my hobby and it's the best way to learn. So let's check the fuse. We're looking for a beep. We get a beep on the fuse. That's good. That cap's not short either. We're going to go straight up to M92 and check all of that stuff first. Let's check the CPU cap. Okay, so no beep there. That's good. 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 Okay, P13 isn't shorted as far as I can tell so far. Now these caps up here. No shorts on N92T36. This is nice. If we go down to BQ, let's check this coil. We're supposed to have continuity. We do still have continuity. That's pretty good, considering that this was badly water damaged. Now we've given it a clean, it doesn't actually look that bad. Okay, this cap here, all good. This cap, supposedly all good as well. This cap, all good. All good. All good. All good. Wow, okay. On the face of everything, we look okay, but it depends on how much water damage has actually sunk into the core of this Nintendo Switch to make it break. And I think we've got pretty lucky, to be honest. I'm also going to do some poking around here to see if we have any shorted caps. We have no shorts in this area that would indicate a bad chip here. If we slide over to this place, the Max IC, this was absolutely ruined before. Do we have any shorts on any caps around here? Again, nothing that indicates a short on the Max chip, or a shorted component around the Max chip, should I say. Let's get a new charging port on here, because I just want to see if we can then get the Switch to work. If that's the case, I do still want to replace some of these charred components. I want to make sure it works first. So let's do that now. how we are looking after we've done the port swap, and it's not looking horrendous. The back is also really, really good. Bit of a Mount Rushmore going on over here, but you can see that all the solder has flowed through really nicely to the other side, as you can see. Look at this, look. This one's extra secure. It's not going anywhere. Let's just have a look at the pins and make sure they are solid after the cleaning. Yeah, seem to be all fine. I do want to put the NAND back on just to see if we get any regular sort of readings. So I'm going to test that now. So you might be asking, what are we looking for when we plug this in? I've got the NAND placed on the board, and all we're looking simply from this amp meter is for it to show 15 volts, both sides, and maybe 0.04 or 5. If we get that, we're looking really, really good. First off, we get a reading, that's really good. However, we get 0 amp draw. Can you see we get nothing? If I move this around, I think the port's really secure. Let me just turn it around as well. And we plug it in. Yeah, we get a reading both sides, which is really, really good. However, it's not performing as it should. Could be the charging chip BQ, or it could also be M92. The fact that we're getting 14.8 volts actually tells me that I don't think it's M92. I could be wrong. So let's go back under the scope and do a bit more investigating. I've had another check for the caps around BQ and nothing's changed. So what I'm thinking of doing is replacing this cap, this cap, this cap, and the BQ chip to see if that makes a difference. So let's do that next. I know that that wasn't the prettiest of jobs. And to be fair, I need to clean up these blobs that are on the BQ chip. Let me just run the iron over here. What was I saying? Yeah, it's not the best job, and I know that, but I don't think this cap is necessarily necessary. I believe it's just a smaller filter for this cap here. This cap replacement was a bit of a pain, and again, that's because I messed it up. This one I chose to use a soldering iron just to make sure that we are all secure, which we are. And obviously we have the BQ chip, which looks a tiny bit wonky, but I can assure you that every single pad seems to be connected. Let's plug in the amp meter and see if we get anything different. Let's go. 0.02. 0.04, no shot. It's just gone back to 0.00. But that did show something different. Let's try this side. 0.00. We haven't got the 0.04 this side, but we did see something different just then. Let me try again. 0.02, 0.04. What happens if I leave it? Does it just goes down to 0.00? I think that's because the CPU's turning on there. It's getting hot. Just shuts off. Let's try this side. This side we just get 0.00. Let me put it back in the housing and see what's going on and see if I get anything on the screen. I have just noticed as well, before I put this back in, I didn't actually check the ribbon cables for corrosion, but we have quite a bit of corrosion on this one. And we have it, yeah, we got quite a lot of corrosion on the backlight cable as well. It's gonna be quite difficult to see. So I'm gonna clean those up before I put it back in the case. Moment of truth. Do we actually get anything on the screen? Here we go. So we're looking for, you know where. 3, 2, 1. Get a reading, 0.06, 0.07, anything on the screen? No, unfortunately not. Different behavior now though. Remember on the back is where we had an issue with it flickering. So do we get that flickering stuff? No, we don't. So we get a solid, so we get the same on the back as we do on the front, which is good. Is the backlight on? No, I don't think the backlight is on. What I'm thinking is reflowing the Max IC chip on the back of the board to see if that makes any difference. If water has got underneath that chip, it could be shorting out maybe 1 or 2 of the pads underneath. I don't have any of those chips as a replacement, so I can't just replace the chip. I'll also reflow the backlight chip to see if that makes a difference. One thing I do actually want to check is if the battery is charging, because then I can write off the BQ area and just say, yeah, I'm done with that for now. I just want to see if the battery's actually charging now, so I'm assuming it wasn't before. You can see that the battery's taking charge. You see that number going up? Well, it's gone to 3.2 volts. What the flip? Wait. 0.49? I've got up to 0.49 amps. Wait, so how much charge does this battery have? 3.2 volts. Look at that. Wait, what's going on? 3.3. 3.35. And look how quick that's going up. So I think the charging circuit is fine. But why do we now have 0.48 amps? Do we have 0.48 amps on both sides? Yeah, we do. So this switch is technically now working, but there is an issue with the screen element. I'm going to go ahead and take this working LCD from this switch and take the board from this one and swap them over and see if that works. After a massive mess, I've now managed to swap our board that we were just working on into this new case. And this new case obviously has a battery. So let's see what happens, shall we? Do we get an image? Is it the board or is it the LCD? Okay, we get 37 amps, 49 amps, but we get nothing on the LCD. And this LCD is fine. I know that for a fact. This LCD is fine. And if I push the on button as well, which I've also plugged the ribbon cable in for the power button, nothing is happening. Okay, back to drawing board. So I'm going to try and reflow this. I think this is the audio IC, so it shouldn't really have an effect on it turning on. However, I'm going to reflow it because that's where we previously had damage. I'm also going to reflow this Max IC chip here, and I'm going to reflow this little guy here, probably this little guy, and maybe even this little chip here, because I don't know which one of these is the backlight driver. So I couldn't be this one. I might try and reflow that as well. I think it's this one. Lord knows what I ended up reflowing and not reflowing. I tell you what, I don't think there was a chip that didn't get reflowed, but let's see if that has made a difference. Come on, imagine if it has. I'll be extremely shocked. 0.37 amps, 0.49, still nothing on the screen, unfortunately, with the exact same error. We've managed to eradicate the fact that it was flashing before and the fact that it was 0.00 amps when it was just a board with the memory attached. So I'm going to go ahead and claim that maybe we did fix the charging circuit, which sorted the battery out. This is still the new case, by the way, but there's clearly still something wrong with this board, which means it's not portraying an image. But just for clarity, this in itself is regular behavior for a Nintendo Switch. 0.39 straight up to 0.48 and 15 volts charging. We gave it a very good go. I'll go ahead and put this one to the side for the time being. It's unfortunate we weren't able to fix it, but today was very, very good soldering experience, and I believe I also fixed the charging port, so that's a plus. If you think you know what the issue is, just type it in the comment section down below, and maybe I'll do a revisit on this Switch. Check out this video where I try to fix a bunch of broken Nintendo Switches. Thank you so much for watching. Have a great rest of your weekend, and I'll see you in the next one. Peace.